Good morning one and all. In previous video we seen what is the antenna array, how it behave, which is the basic mathematical equations we find out, and based upon that the radiation pattern is generated. For this point, the next case we will going to discuss it. For next case, we see in the origin at element 1. For this case, the isotropic point source 1. For this case, isotropic point source 1 and isotropic point source 2. In previous case, the isotropic point source 1 is located on the negative x-axis and isotropic point source 2 is located on the positive x-axis, and which is separated by the distance with respect to the origin d by 2 and d by 2. Hence, the total distance is the d. For this case, the origin at element 1, the isotropic point source 1 and isotropic point source 2, which is separated by the distance d and which is located at origin, and from that distance we have to be able to measure dr cos phi, and your isotropic point source 2 is located, and to measure the angle with respect to the distance point which is equal to phi, and here is the phi which is equal to 0, and to measure from isotropic point source 2 to the distance point. Hence here the phi which is equal to 0, for this case the phi which is equal to 0. The mathematical equation is given E which is equal to E0 1 plus e raised to j psi, and this equation we have able to convert in the trigonometric function. Hence, to multiply by 2 and divided by 2 means again it will be reformat into the original equation. Hence 2e0 e raised to plus e raised to j psi by 2 means here e raised to j psi by 2 is taken as a common, means once it is the multiplying inside the bracket term, the original equation is formed. Hence the 2e0 which is equal to 2j e raised to j psi by 2 plus e raised to minus j psi by 2 upon 2. What it indicates that the exponential function, the exponential function, it is represented by the angle. Means here 2e0 e raised to j psi by 2 cos psi by 2 and psi which is equal to dr cos phi, we know that. The normalizing the equation, this equation should be normalizing by this equation, again the 2e0 which is equal to 1. For this equation 2e0 which is equal to 1, hence e which is equal to e raised to j psi by 2 cos psi by 2 and cos psi by 2 at an angle of the cos psi by 2. See here, basically for this, the mathematical equation we have to be find out based upon this vector diagram. For this vector diagram, there are the two sources is available. One source is available from the source 1 and here is the from source 2. From source 1, E0 from source 1 and E0 from source 2. Basically the source 1 and source 2 which is separated by the distance d. And e raised to j psi by 2. Basically psi is represented by the angle. And for this case what we seen, isotropic point source 1 is located at the center. Hence the angle is 0. Hence e raised to 0 which is equal to 1 for this case. E raised to 0 which is equal to 1. Hence e raised to plus j psi by 2 which is located from the source 2 and e raised to minus j psi by 2 means actually it is the j psi by j psi and psi which is equal to 0, e raised to 0 which is equal to 1. Hence this is the equation E0. From this vector diagram, the red line itself, it will be indicated by the total resultant electric field E, and the green arrow indicated means with respect to this red point from the source 1 and from source 2, its angle is represented by psi by 2 and psi by 2. Then for the next case what we seen, for the next case there are the two isotropic point sources of the same amplitude and the opposite phase. In the next case what we learn, the resultant electric field E which is equal to E0 e raised to plus j psi by 2 minus E0 e raised to minus j psi by 2. This minus sign itself in the previous case, what the two isotopic point source of the same amplitude and the same phase. In the same phase, here is the plus sign, and itself it will be plus sign is indicated by the two isotopic point source 1 and 2 are in phase, and the minus sign itself it will be the minus sign, it will be indicated by the two isotopic point sources is located on the opposite phase. Means this minus sign is indicated by the two isotopic point source are in the opposite phase. Hence E which is equal to 2j E0 sin psi by 2. Means after E0 should be taken as a common and E raised to plus j psi by 2 is also taken as a common. Then 2j divided by 2j and multiply by 2j. Again this 2j gets cancelled, then it will be reform the original equation. Then E which is equal to 2j E0 sin psi by 2 which is equal to 2j E0 sin dr cos phi upon 2. Means this psi which is equal to dr cos phi upon 2. Dr is a stands pi at a distance point we have able to measure the electric field E. Here the isotopic point source 1 and isotopic point source 2 which is located on the opposite axis, means plus positive x-axis as well as on the negative x-axis, and which is separated by the distance d, and d which is equal to lambda by 2. Hence this equation we have to be reformed, E which is equal to sin pi by 2 cos phi. Then phi, if you have to be able to measure to find out the resultant electric field E, for this case two isotopic point sources of the same amplitude and the opposite phase. For this case what we learn, the phi which is equal to 0 degree and phi which is equal to 0 degree, then E which is equal to 0 because sin 0 is a 0. Okay, cos 0 is 1, but here is a sin 0 is a 0. Sin 90 for psi which is equal to 90 degree, then your resultant electric field E which is equal to 1, and for E for 60 degree which is equal to 1 upon root 2. Then next case we have seen the two isotopic point sources of the same amplitude but 90 degree phase difference at lambda by 2. For this case the E which is equal to E0 exponential function, the same function mathematical equation we have to find out, E which is equal to E0 exp plus j dr cos phi upon 2 plus pi by 4. Means in phase quadrature. Basically the two isotopic point sources of the same amplitude with 90 degree phase difference at lambda by 2 means your overall phase shift is the pi by 4. Means for this equation, finally this equation we have find E which is equal to 2E0 cos pi by 4 plus dr by 2 cos phi, and normalizing this equation, for this normalizing equation 2E0 which is equal to 1 and d which is equal to lambda by 2. Hence the normalizing means 2E0 which is equal to 1 and d which is equal to lambda by 2, means here is the lambda by 2. This equation we have formed E which is equal to cos pi by 4 plus pi by 2 cos phi. Okay, means for this equation what we learn, there are the different angle how much the electric field is obtained. For this case phi which is equal to 0 degree, 60 degree, 90 degree, 120 and 180 degree. Then E for phi which is equal to 0, cos 0 which is equal to 1, then cos pi by 4 plus pi by 2, then here is the 2 pi, 3 pi by 4, means the value of the electric field E which is equal to 1 upon root 2. Then 60 degree, 90 degree, 120 degree, 180 degree respectively the electric field E is obtained. For 60 degree it is 0, for 90 degree it is the 1 upon root 2, for 120 degree it is the 1, for 180 degree it is the 1 upon root 2. In this way we have to be getting the radiation pattern for two isotopic point sources of the same amplitude and in phase quadrature. Then this is the radiation pattern. What is the shape of the radiation pattern? This is the radiation pattern, cardioid shaped of the radiation pattern we want to getting here. Means the maximum radiation you want to getting for plane number 2, plane number second and plane number third, means first, second, third and fourth. There are the fourth quadrant. In the first quadrant and the last quadrant, means fourth quadrant, the minimum radiation you want to getting along the x-axis at an angle of the 0 degree, and you want to getting the maximum radiation in the second as well as third, means for this two quadrant you want to getting the maximum radiation. Maximum means this is the cardioid type of the radiation pattern to getting for this type of the antenna array, means two isotropic point sources of the same amplitude and in phase quadrature. See, next case. For the next case, you want to getting two isotropic point sources of the same amplitude with 90-degree phase difference. For the 90-degree phase difference, what we getting here, see, for this case, the spacing between the source is reduced to lambda by 2 to lambda by 4. And if we want to reduce the distance between the two isotropic point sources, the final equation is E, which is equal to cos pi by 4 plus pi by 4 cos phi. And its radiation pattern, it hurt type of the shape. Okay, means here the maximum radiation you want to getting for second and third quadrant only rather than the first and fourth quadrant, and respectively the phi is varying from 0, 90, 120, 150, 180 degree. You want to getting the radiation pattern E, which is equal to 0, 1 upon root 2, 0 0.924, 0 0.994, and at 180 degree it is the 1. Then the another case is that the two isotropic point sources of the same amplitude with any phase difference. Means in the previous case there is a respective